Hey everybody, happy Wednesday. Sorry that I'm not able to be with you, but we will pick this up tomorrow. And just remember, tomorrow we'll talk about both the first and the third worksheet from Target 2, the worksheet on factoring and this worksheet here on quadratic formula. Now, you all remember, hopefully, the quadratic formula, since it is written right above here, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This formula comes from taking our general form here, substituting 0 for f of x, and then solving for x, leaving a, b, and c as variables. It's a long process. It involves completing the square. It gets messy with fractions. The important thing is you have the formula. We need to know how to use it. I'm not going to be overly concerned with how we got the formula. One piece of the formula which we did not necessarily highlight in algebra was the radicand, the expression that's underneath the radical there. That has a special name, and it is called the discriminant. We've been working with quadratics and determining what types of zeros that they would have, and the discriminant, there's a way once you simplify the discriminant value, that value will tell you right away whether you have 2 reals, 2 imaginary, or 1 repeated real zero. So let's just dive right in. We have a function here. We know we are looking for zeros, right? So we're looking for zeros. So what that tells me is that f of x equals 0. So I can use the quadratic formula. So essentially we're replacing 0 with f of x, and I know a is 3, b is -5, and c is 2. So I mean, really guys, at this point it's just a matter of substituting and simplifying here. So I'm going to take the opposite of -5, which is +5, plus or minus the square root of b squared, so -5 squared, minus 4 times a times c, all over 2a. All right, it's just that simple. Plug it in and out. I would expect that you can just take this entire expression, -5 squared minus 4 times 3 times 2, and just put it in your calculator and simplify it. The one thing you got to be careful of, guys, please, put the -5 in parentheses in your calculator. Otherwise, you're going to get a wrong answer because you're telling your calculator to not do what you want it to do. So this would be 25, 12 times 2 is 24. So that would all simplify to just +1 underneath our radical square root symbol, and then obviously 2 times 3 is 6. Now this is where if you stop here, you are going to lose points. We would expect you to understand that the square root of 1 is indeed 1. So this is really 5 plus or minus 1. And again, we can simplify this further, because 5 plus 1 divided by 6 is a specific value, and 5 minus 1. So 5 plus 1 is 6, 6 divided by 6. So one of my zeros would be +1. 5 minus 1 is 4. 4 over 6 would simplify to 2/3. All right, so we would have, in this case, 2 real zeros there. Let's take a look at b. So again, in b, I'm putting 0 in for f of x. Now, my a value here is hiding. It's a ninja. Don't forget that if you have no visible leading coefficient, or any coefficient, that it is 1. So we're going to go again. So x is going to be equal to -4 plus or minus the square root of 4 squared minus 4 times 1 times 2. Yep. And we are going to then have all over 2 times 1 here. So in this situation, we're going to end up with -4 plus or minus the square root of 8 over 2. Now, square root of 8, it's not like the square root of 1. 1 is a perfect square, 8 is not. So we have to be able to simplify a square root of 8. So I'm just going to come over here, because you probably don't have enough room on the page, and work through simplifying the square root of 8. Again, what I'm going to do is I'm going to factor 8 down to its prime factorization, and then try and find factors that I can write with a power of 2 so that I can cancel the root of 2. So 8, I can go 2 and 4. I can go 2 and 2, so the prime factorization of 8 is 2 times 2 times 2. Now I want to write this prime factorization so that I have something squared if possible. Well, I can write this, instead of 2 times 2 times 2, is 2 squared times 2. So I can replace underneath my radical here, I can replace 8 with 2 squared times 2. Now, why does that matter? Well, again, remember we can split this radical term into 2 radical factors, and now on one of them, the exponent of 2 cancels the radical, and so we end up with 2 square root of 2. So this is what I would expect you to do in simplifying the square root of 8 there. So we're going to come back over here, and instead of square root of 8, I'm going to have negative 4 plus or minus 2 square root of 2 over 2. Well, again, we can simplify this further because you recognize negative 4, 2 square root of 2, and 2 all contain a factor of 2. So if I were to divide out, cancel a factor of 2 out of each term, you can see what I'd be left with for x is negative 2 plus or minus the square root of 2. I guess I'm going to do that. I don't need a denominator here. Why highlight? Thank you. There we go. Don't need a denominator because my denominator is 1. And yes, guys, these are your zeros. All right. Now they are still 2 real zeros. All right. These are 2 real zeros, but because this is going to be an irrational number, we just leave it in its radical form there, and that's fine for right now. If we ever needed to apply this in real life, we'd have to do a little bit more work there, but we're okay with it right now. So let's take a look at the last one here. The last one here, A, B, and C. All right, so we're going to end up with x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 all over 2 times 4. So if we look inside our radical here, 4 squared is 16, 4 times 4 is 16 times 1, this all becomes 0. What we actually have here is the square root of 0. Well, the square root of 0 is just 0, and negative 4 plus 0 and negative 4 minus 0 is just negative 4. So what I end up with here is not 2 zeros, because the plus or minus is what really causes me to have 2 zeros in this formula, but I have just 1. And negative 4 over 8 simplifies to negative 1/2, so my 0 is negative 1/2. So in this case, I have 1 real 0. All right. So hopefully how we used the quadratic formula made sense here, and actually I realized I miscalculated a little bit on B. I actually wanted that value under the denominator to be negative 8, but we'll work with it because I'm not there to change it with you in class. So let's talk quickly about the discriminant though. So just to remind you, the discriminant is the value that you get when you simplify underneath the radical, right? So the discriminant were those values right there in red. So let's take a look. So in the first two, you can see that my discriminant is a positive number. And both times that it was a positive number, the zeros are 2 real numbers. Right? Now you can see in the third option, it was not a positive number, it's simplified to 0, right? And my 0 was 1 real number. Now, that leaves us with only a third possible option. The discriminant could simplify to something positive, it could simplify to something 0, it could simplify to 0, or it could simplify to something negative. Well, by process of elimination, even though I did not have an example above, the only alternative left to us is that we would have 2 imaginary numbers for our zeros. All right, so just by as soon as you simplify the radicand here and get our discriminant value, you should know right away whether you're going to end up with 2 reals, 1 real, or 2 imaginary zeros. All right, well, that's the quadratic formula. Please work on this in class. Please work on the homework, and then on Thursday, come to class with questions on both the on the worksheet that we did part 1 here with factoring and using zero product property, and part 3 with the quadratic formula. And together in class on Thursday, we'll review and work with completing the square. Hope you have a great Wednesday, and I will see you tomorrow.